Dear students, welcome to Loksatta Yashasvi Bhava. Hope you must have enjoyed your Ganpati festival and now you must be preparing for your first term examination. In this session, we are going to study the third chapter in algebra, whose title is Linear Equations in Two Variables. Last year, the fourth chapter having the same title you have studied, and therefore you are familiar with this chapter. Last year you have studied method of solving simultaneous equation, the elimination by equating the coefficient and elimination by method of substitution. After that you have studied the application of the simultaneous equation in word problems. Now this year's 10th standard linear equation in two variables chapter is just the extension of last year's chapter. This chapter includes the following units. Let us study the graphical method of solving simultaneous equations. Last year you have studied how to plot the points on a graph paper. You have also studied how to draw the lines when linear equation in one variable is given and linear equation in two variables is given. Now this will help you to solve the simultaneous equation in two variables by graphical method. Let us take an example for it. Solve the following simultaneous equations by using graphical method. The equations are 2x minus y plus 5 is equal to 0 and x plus 4y is equal to 2. When last year you studied how to draw a line, or you have studied that a linear equation in one variable and two variables represents a line on a graph. You have studied how to draw a line when a linear equation in two variables is given. For that we prepare a table. Now in this table we have two solutions of each equations we have taken. Here for 2x minus y plus 5 is equal to 0, we have selected the value 0. For the corresponding value of y is 5. For x is equal to minus 1, the corresponding value is equal to 3. Now for the second equation, x plus 4y is equal to 2. X is equal to 2, the corresponding value is 0. When x is equal to 6, the corresponding value of y is minus 1. You know that these 0, 5, minus 1, 3 satisfies the equation 2x minus y plus 5 is equal to 0 and 2, 0 and 0.6 minus 1 satisfies the equation x plus 4y is equal to 2. While solving this simultaneous equation by graphical method, many students they try to express y in terms of x, and in doing so many times they make a mistake. So I would advise you that keep the equation same and select values of x and such that the values of y which you are going to get is an integer. For the first equation 2x minus y plus 5 is equal to 0, you will find no problem in selecting such type of values. But when the coefficient of y is other than 1, when here the coefficient of y is 4, while selecting the values of x, you have to be careful here. If you take the first value of x here, x is equal to 2, we get an integer 0. We are going to see one simple trick in getting the other values of x and y. Now here you will find the coefficient of y is 4. Now the first value of x is 2. If you add 4 to it, then you are going to get the value 6, and for that value the corresponding value of y will also be an integer. Now you will find in this table that we have selected only two solutions for both the equations. But in examination, many students they take the third solution also. For that, two solutions are enough for drawing the equations. If you see the graph paper here, then you will find we have plotted the points 0, 5 and minus 1, 3, and we have drawn a line. We have 2x minus y plus 5 is equal to 0. Then we have plotted point 2, 0 and 6 minus 1, and we have joined these 2 points to draw the line x plus 4y is equal to 2. Now these 2 lines, they intersect in a point minus 2, 1. Now this point, you will find that it is common to both the lines. That means this point satisfies both the equations, and therefore this is the solution for the simultaneous equation 2x minus y plus 5 is equal to 0 and x plus 4y is equal to 2. In examination, be careful and write the answer, the final answer, as the point of intersection of the lines 2x minus y plus 5 is equal to 0 and x plus 4y is equal to 2 as minus 2, 1. And therefore the value of x is equal to minus 2 and y is equal to 1. This point satisfies both the equation, and therefore it is the solution of the 2 equations given to us. Let us see the second method of solving simultaneous equations. It is called a determinant method of solving simultaneous equations, or solving simultaneous equation by using Cramer's rule. Now let us see first what is the meaning of a determinant. Now if we consider any 4 numbers, say A, B, C and D, then the value AD minus BC can be represented by using a determinant of order 2 as A, B, C and D with 2 parallel vertical lines, and the value of this is AD minus BC. Now this determinant has 2 rows and 2 columns, and therefore this is a determinant of order 2. There are higher order determinants also. Now let us take an example of finding the value of a determinant. Here, find the value of the determinant is 4 minus 3, 2 minus 1. Now for finding out the solution, you will find you have to always start with the number which is at the left hand side top corner and multiply it with the right hand side top bottom number. Here we get 4 multiplied by minus 1 is minus 4. Then minus the right hand side top corner number multiplied with the left hand side bottom number. Here it is 2. So minus 3 into 2 is minus 6, and minus minus 6 is plus 6. Therefore we get 4 into minus 1 is minus 4 minus minus 6, that is equal to plus 6, which comes out to be 2. And this is a simple introduction to the determinant of order 2. Now let us see its use for solving the simultaneous equations by determinant method. Let us consider the following simultaneous equation, which is written in general form. A1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. Now if you want to solve this simultaneous equation by the method which was studied in standard 9, by equating the coefficient, what we do is we can multiply the first equation by a2 and the second equation by a1 and make the coefficient of x same and then eliminate it. Then you will arrive at the values of x and y. You get the value of x as c1b2 minus c2b1 upon a1b2 minus a2b1. If you substitute this value in the equation, you are going to get y is equal to a1c2 minus a2c1 upon a1b2 minus a2b1. If you look at these values of x and y carefully and the concept of determinant, you will find that c1b2 minus c2b1 and A1B2 minus A2B1 and A1C2 minus A2C1 can be expressed in a determinant form. If you look at C1B2 minus C2B1, it can be expressed as the determinant having C1B1, C2B2, and if you see the value, we get C1B2 minus C2B1, which is the numerator of the value which we get for x. The denominator A1B2 minus A2B1 can be expressed in the determinant form by using A1B1, A2B2, whose value is A1B2 minus A2B1. Similarly, the value of y which we get A1C2 minus A2C1 can be expressed in determinant form as A1C1, A2C2, where we get the value as A1C2 minus A2C1, where the denominator is as it is, that is d. Now this C1B1, C2B2 determinant is represented as dx, and A1C1, A2C2 determinant as dy, and A1B1, A2B2 as determinant d. If you look at these values and this determinant, therefore we get x is equal to dx upon d and y is equal to dy upon d. If you use this method for solving the simultaneous equation by using the determinants dx, dy and d and find the solution of the simultaneous equation, we are using the method of solving the simultaneous equation by determinant method. This method is also called as by using Cramer's rule, solving the simultaneous equation by using Cramer's rule. Let us now see an example for solving the simultaneous equation by determinant method. Here the question is, solve the following simultaneous equation using Cramer's rule. The equations are 5x plus 4y plus 1 is equal to 0 and x is equal to y plus 10 upon 2. Student, you should always follow certain steps while solving the simultaneous equation by determinant method. What you should remember is whatever equations are given to you, first express this equation in general form. So we have done it here. 5x plus 4y plus 1 can be expressed as 5x plus 4y is equal to minus 1 and x is equal to y plus 10 upon 2 can be expressed as 2x minus y is equal to 10. Now let us find the values of the three determinants d, dx and dy. Now for finding the value of d, dx and dy, it is preferable that you write these two equations one below the other and find the values. If you see the value of d, and d is equal to a1, b1, a2. Here the values of a1 is 5, b1 is 4 and c1 is minus 1 and a2 is 2, b2's value is minus 1 and c2 value is 10. The value of the determinant d is, if you take 5, 4, 2, minus 1, you find the values of this. 5 into minus 1 is minus 5, 4 into 2 is 8, minus 5 minus 8 comes out to minus 30. Whereas the value of dx, we get c1, b1, c2, b2, which is minus 1, 4, 10 and minus 1. The value of this, as you already know, it is 1 minus 40, which comes out to be minus 39. Similarly, the value of dy is a1, c1, a2, c2. If you substitute this value, we get 5 minus 1, 2, 10, and the value of this determinant is 50 plus 2, that is equal to 52. And therefore, by using Cramer's rule, we know x is equal to dx upon d, that is equal to minus 39 upon minus 13. The value of x comes out to be 3, whereas the value of y is equal to dy upon d, that is equal to 52 upon minus 13, which comes out to be minus 4. And therefore, the value of x is equal to 3 and y is equal to minus 4 is the solution of the given equations. Now in the later on part, when you are going to study the higher order thinking skill problems which are given at the end of the textbook, you will find that this method helps you to solve the complicated examples which we are going to see in the later part. Student, you must have referred to the articles in Loksatta Yashasvi Bhava and the textbook. Now we are going to study the next part of the chapter, that is consistent and inconsistent simultaneous equations. Let us first study the meaning of consistent and inconsistent equations. Now, do you know that every simultaneous equation, does it have a solution? All the simultaneous equations, they might be having solution or they may not have solutions. Now, if the simultaneous equations have solutions, such type of equation we call it as consistent equation. If the solutions are not there, such type of simultaneous equation we call it as inconsistent simultaneous. Know whether the simultaneous equations have solutions or they don't have solutions. Let us go back to the two simultaneous equations which we have considered in general form, that is a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2, and already we have seen the solution of that. X is equal to c1 b2 minus c2 b1 upon a1 b2 minus a2 b1, and the value of y as a1 c2 minus a2 c1 upon a1 b2 minus a2 b1. Now if you look at the values of x and y, you can find that if the denominator a1 b2 minus a2 b1 of the value x as well as y, you will find if this value is not equal to 0, that is a1 b2 minus a2 b1 is not equal to 0, and we get a1 upon a2 is not equal to b1 upon b2. In such type of equation, you will find that the solution is always unique, and as it has solution, we will call such type of simultaneous equation as consistent equations. Whereas if a1 b2 minus a2 b1 is equal to 0, we arrive at two conditions. First one, a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, and a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Let us consider the first condition, a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. In such type of simultaneous equation, you will find that there are infinite solutions, and therefore as these equations have solution, they are consistent. When the condition is a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, you will find there is no solution to these equations, and therefore these equations are inconsistent. Let us see now the graphical interpretation of consistent and inconsistent simultaneous equations. Let us take an example of two equations, 2x minus y plus 5 is equal to 0 and x plus 4y is equal to 2, which already we have studied in the previous example. If you draw the two lines representing this equation, 2x minus y plus 5 is equal to 0 and x plus 4y is equal to 2, you will find that these two lines, they intersect in one point, minus 2, 1, and if you see this two equation, and you will find in this case that if you represent 2x minus y plus 5 is equal to 0 and express it in general form, and the equation x plus 4y is equal to 2, which is already in the general form, find the values of a1, b1 and c1, a2, b2 and c2, you will find here in this case that a1 upon a2 is not equal to b1 upon b2. In this case, you will find that there is a unique solution which we get. Let us take second example. where two equations are there. 2x minus y plus 5 is equal to 0, and the equation 6x minus 3y plus 15 is equal to 0. Again, express these two equations in general form. Get the values of a1, b1, c1 and a2, b2 and c2. If you look at the values of a1 upon a2, b1 upon b2 and c1 upon c2, you will find that these values are same, and you will find that the graphical representation of these two lines, that these two lines, they are overlapping lines or coincident lines. Therefore, each and every point on this line is intersecting with the other line, and therefore each and every point on this line is the solution. And therefore, in this case, when the condition is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, you will find that there are infinitely many solutions. And as the solutions are there, therefore in this case and this case, we say that the equations are consistent. Let us take another example. The equation 2x minus y plus 5 is equal to 0 and 2x minus y minus 3 is equal to 0. Again, express this equation in the general form. Get the values of a1, b1, c1 and a2, b2 and c2. You will find here that the two lines, they are parallel to each other, and if you take the value, then a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. As these lines are parallel, therefore they are never going to intersect each other, and therefore these two equations having the condition a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2 does not have any solution, and therefore these lines, these equations are inconsistent. The next part of the linear equation in two variables we will study in the next session.